session of the present and future of offsite fabrication. There is a third session next week, which is more focused on the detailed engineering side of things. You are all welcome. There's quite a lot of content to go through. There will be a Q&A session at the end, so please feel free to write your questions in the chat and we will run through them at the end. And I will hand over to one of our speakers, Neil Ross.
Thanks, Gonzalo. Next slide, please, Joe. Good afternoon, everyone. Welcome back to those who joined us last week, and hello to those of you who are joining us today for the first time. I'm Neil Ross. My role is an M&E engineering leader within Laing O'Rourke. So last week, during our first session, we provided an overview of the application of a dfMA process and the implementation of offsite MEP products. We shared our view on the benefits and the opportunities which could be realised as a result. This week, we're going to look forward into the future, and we're going to explore how the dfMA process could be enhanced if we considered our approach from a product perspective and effect designing using standardised components. You'll probably hear me refer to products quite a lot during this presentation, and that's really the intention behind this, to start shifting the mindset from bespoke dfMA solutions to more of a product-based approach. Next week, we'll complete the three-part series with some examples of how digital engineering is helping to drive productivity gains in the fabrication and installation stages of the dfMA process. So anyway, back to today's session. During our presentation, Gonzalo will double back on the current project lifecycle workflow and propose an alternative workflow using a product-based approach in order to drive the step change in productivity our industry requires. I will then explain the benefits which could be materialised should a product-based approach be followed. And Joe will present an overview of an alternative design process using products and digital configuration tools, and we'll complete today's session with some examples of product strategies and configuration rule sets. Andy from Horley will be on hand to support the conversations around digital workflow, which Joe will introduce, but Andy will be there to introduce it from a consultant's perspective. Next slide, please, Joe. Okay, so presenters as per last week, Joseph Lally and myself, we both work for Laing O'Rourke. Joe is the digital engineering lead within Crown House Technologies, and I'm a mechanical and electrical engineering leader within Laing O'Rourke. Next slide, please. Andy joins us from Horley, who is part of their digital development team, and he heads that up for them. Okay. And we've obviously got the bio here that you can read through at your leisure once we circulate the slide deck. Okay, so for those of you who are not able to join us last week, I'll provide another short overview of the company that Joe and I work for, just so you can perhaps place some of the intent behind what we're communicating. Laing O'Rourke is a privately owned international engineering enterprise with world-class capabilities spanning the whole of the client value chain. The business's mission is to become the recognised leader for innovation and excellence in the construction sector. We've got a mature digital engineering and design for manufacturing assembly offer, which hopefully is coming through these series of webinars. We strive to improve the productivity and profitability. It's one of the key drivers for us within the business, and we're continually developing our innovation and sustainability agendas as key focuses. We've got a significant manufacturing capability. It stretches across 4 manufacturing locations, mostly in the Midlands. Our Centre of Excellence for Modern Construction at Explore Industrial Park and Workshop is the most automated concrete products facility in Europe. We have a GRC manufacturing facility in Doncaster. We've got a volumetric facility in Manton Wood where we make our bathroom pods, internal partition systems and utility cupboards. And last but not least, we've got our M&E facility in Albury, which is celebrating its 25th year in operation this year. I'm now going to hand back to Gonzalo, who will discuss the current and the proposed workflow. Next slide, please, Joe.
Thank you, Neil. Yeah, basically, this is what you see in the screen addressing a workflow, and basically what the quality and productivity benefits of offsite manufacturing within the construction industry are understood. the reality is that the vast majority of projects are still being delivered using traditional methods. This might be because people still don't understand the benefits, or maybe because when modern methods of construction are adopted in a project, it is often a bit too late. So it's more when a contractor engages with the project, and it normally results in long periods of redesign during the construction stage. There have been a lot of ideas being put forward, promising a smoother transition between design and construction, which will definitely lead to shorter program lengths and reduce costs. But even with this, even people understanding the benefits, tradition still sticks. So basically, a step change is needed that unlocks optimized construction and extends efficiency throughout the delivery cycle. So you can see on the screen, in yellow, that represents more the design or the design and consultant phase, which basically just when you start getting the client brief, start developing the concept, and then you do your design. The thing is, maybe the bar at the bottom, you can see that the implementation of dfMA solutions generally in the traditional workflow, they start really late. Maybe it's when in the tender process, or if there is a PCSA agreement with the contractor, that's when they start maybe putting forward proposals like bathroom posts or utility cupboards. But the problem is maybe that if the design hasn't considered those from the beginning, there needs to be a redesign, or sometimes it's a small redesign, or sometimes it could be just proper. Well, it could be literally thrown in the bin and starting from scratch, and that definitely is really, really inefficient. So if you go to the next slide, Joe. So this shows more the workflow with a product-based building solution. So basically, the idea is to start thinking about, especially to promote a product-based approach to construction by considering products from the beginning of the design stage, and that basically will result in an increase of efficiency. We have compared some metrics, several key metrics to demonstrate what we think the benefits will be. And first of all, it will be a smoother transition, so it will be less overlap between the design and construction. And then it will lead to better design coordination, minimizing future changes or rework by the installer, so there are more accurate programs and reduce cost and greater cost certainty for all parties, better quality product as well, reducing snagging and remedial works, and also minimizing waste in construction, which also could lead to carbon reductions. So I think basically what we say that the product-based solutions applied at the start of the process can potentially provide this step change needed to radically transform our industry, traditional way of working. So you see the image on the screen again. It just shows all like a collaborative approach. So contractor, consultant, client, all collaborating from the beginning. It's all the same process, working on the same thing, choosing the products that are going to be used from the beginning. But basically it is that when the contractor starts the proper construction phase, there doesn't need to be a 6 months period, 8 months period, or 4 months period from one to the other doing some redesign. That has already been considered. And also the other benefit that Andy and Joe will touch on later is probably transferring the data from that design stage to the construction stage, and then also to the building user in the future. So I'm going to hand over back to Neil.
Thanks, Gonzalo. Okay, so let us consider a product-based methodology applied to the automotive industry. What you see on screen is Volkswagen Group's MQB platform. It's a platform which underpins a wide range of cars from the super mini class all the way through to the mid-size SUV class. And that also covers its individual vehicle brands. I think actually it covers 36 different car models. And it's a system for introducing rationality to different models, and it's coordinated around a core matrix of components while sharing common elements. So it goes back to the point I made in the first webinar, where from a process and a products perspective, if you look to standardize the invisible parts of the solution, it gives you the opportunity to customize the visible. So if you imagine across 35 of those car models, which this platform applies to, if you use a product-based methodology, you can really gain significant efficiency in your process by utilizing common parts, predefined elements, and given the flexibility for designers to create the aesthetic differences between each realisation of the solution. Next slide, please, Joe. So if we think about that in the construction sector and what that might mean to us, some of you might be aware of the platform dfMA strategy, which has been proposed by Bride and Wood. It's represented in the image on this slide. It's essentially based on the principle of a library of kit of parts, and they're defined as either sector specific or cross sector. So there might be parts that are applicable to purely commercial, or there might be parts that apply to commercial, healthcare, residential. Configurable assemblies can be built up using the kit of parts and the use of digital tools to enable automated design for repeatable elements, or parametric configuration for those requiring more in-depth subject area knowledge can be facilitated. So really, if we are looking to gain productivity gains, the whole concept around having defined standardized components really will let us get to that stage. Next slide, please, Joe. If you recall, last week we presented these metrics, which are on screen. Internally within Laing O'Rourke, we use those to outline the benefits of following a dfMA process, with these benefits mostly being realised during the construction phase of a project. So if we're gaining these benefits during construction, then we need to think about how we can actually introduce benefits during the design. So we've got a complete life cycle improvement. Next slide, please, Joe. So if we followed a product and technology-led approach during the design phase, there's potential that we could realise the benefits which are indicated on screen. Using standardised components and an integrated configurable workflow can increase the design productivity and therefore reduce design effort. We've got a metric there of 50% reduction in effort on screen, not measured, predicted perhaps, but it's certainly an indication of if we were smarter in terms of how we configured ourselves during the design process, we could gain some significant benefit. And what that will actually do, in effect of reducing the designer's time associated with repeatable elements, it does give design teams more space to focus on the key challenges within a given project. If we use pre-engineered products, which are developed to fabrication level of detail, that will help to reduce the manufacturing times, as components are known and repeatable manufacturing processes are embedded in the design of the product. So going back to Gonzalo's point about if we start with products in mind, we can embed the detail of the design within the products, therefore the need to revise or revisit design solutions is minimised. So similarly for assembly on site, where defined and repeatable details are introduced, and we work to reduce the interfacing risks between those components, it removes unknowns from the assembly process. A point to note that in product-based approach, you can start to transition from construction to assembly. So the whole way in which you realise a physical asset starts to change if you're then thinking about it from a design, manufacturing, assembly perspective, as opposed to design and construction. So all of this factored in will lead to a more sustainable industry through the better use of materials and control of waste, either in the manufacturing process or in the on-site assembly and construction process. These should help to drive the existing 70, 60, 30 metrics that explained in the previous slide to a higher position where we can actually exceed that. I will now hand over to Joe, who's going to present an overview of an alternative design process using products and digital configuration tools.
Thanks, Neil. And good afternoon, all. So as you've just seen on the last slide, showing the targets, we've set ourselves the target of saving 50% of the design effort required to produce our buildings. And I'm going to talk a little bit about how we believe this can be achieved, focusing mainly on the digital and the design aspects. There are obviously lots of other benefits like manufacturing assembly. And before we get into the design and digital aspects, I just want to mention one really important thing that we need to recognise, and it's repeatability. And I can't stress how important repeatability is. To give you a quick analogy, if we're buying a car, you don't go into a car showroom and ask for a custom built car unless you're absolutely loaded. And it's because it'll just be cost prohibitive. So instead you choose from a set of affordable cars, and the only reason these are affordable is because they're mass produced at huge volume. However, like right now in the built environment, we're not doing that. Each building is almost a custom piece, which, you know, is a massive cost to our clients. And many of the clients that we do have are sort of, the buildings they build are funded out of our own pockets, such as schools and hospitals. So again, I can't sort of stress how important repeatability is, and I'm a huge advocate, and so is Laing O'Rourke, and I'm guessing the guys, you know, on the call with us here, about the need to be mass producing and manufacturing buildings, or at least large parts of them, so they become more affordable. Back to the design and digital stuff. So when we refer to design, we're talking about thinking time, and the modelling time, drawing time, and the scheduling time needed to put all our ideas down onto paper. And in summary, our strategy is to avoid sort of starting each project with a blank piece of paper, which is kind of the traditional approach. But instead, we want to sort of come with, you know, pre-armed with a building platform and a kit of parts, and a kit of parts that's compatible with the platform that we produce. And importantly, sort of a configurable menu of ready-made solutions. So you can see here we've got the product library on the right here, turning these into almost into Lego bricks, and then suitable for each sector. So, you know, on this slide, you can see that we've got almost the complete kit of parts for pretty much any building type in Laing O'Rourke and across all disciplines. And all this is underpinned by a digital toolkit to support this platform. And this includes data environment and product library and configuration tools, all which we'll touch on in a moment. Maybe I think I missed one. Hang on. Yeah, sorry. So as you can see here, all this is underpinned really by client requirements. So this is where the process starts for us really. And it's understanding in detail what the client wants and tailor making our kit of parts and solutions to meet specific needs for the clients, you know, for a variety of different sectors, collaborating with clients, designers and the supply chain. As Gonzalo suggested, it has to be almost from the outset to make sure that this platform's fit for purpose and we're not redesigning stuff and all that waste. You know, we should be thinking about it all at the same time, rather than creating a design out of generic stuff and then redesigning it based upon real stuff. We should just start from the beginning. Personally, I think so anyway. But so yeah, that's that one. So if we get touched there now on the product library, so a key enabler to this is digitalization of the real world, the physical. You know, so that includes sort of digitizing the real products into this digital product library, into a kit of parts. And typically then each of these individual products is also part of another product or a larger assembly of products. And we've called this here our solutions library, but essentially that's bringing all this stuff together in a standardized way. And again, as Neil sort of suggested earlier on, I think one benefit we do have at Laing O'Rourke is the fact that we do actually manufacture a lot of our own products, but we also have a large supply chain that we're engaging with. And we're also in the process of trying to ensure that we standardize and capture their products and how we engage with those guys, making sure the performance data and everything is captured into this platform as well. So how does this work in practice? So this diagram illustrates how solutions, and in this case the solutions here is, you know, a whole space within a building can be completely packaged up into the library, and then the spaces themselves are used almost like Lego bricks. And this enables us to sort of design and plan buildings rapidly at an early stage. And importantly, we're not just playing with Lego here. All of these blocks has some kind of embedded intelligence to enable us to rapidly get time and cost analysis in real time to a reasonable degree of accuracy. And to prove that this isn't just smoke and mirrors, there is actually intelligence behind this that we alluded to, and it's no huge secret or complicated algorithms, which many people think with this kind of approach. It's just simply working all this stuff out up front and making sure they've got the necessary detail in the Lego brick to give us that confidence in the design at an early stage. But again, this just reinforces the need for standardization and repeatability. This will not work if every classroom's slightly different, or you know, the design doesn't follow this repeatable solution. So yeah, just reinforces the need for that centralization of design that we need to do. And I think again that needs to be a joint effort between the client, the designer, and us as a contractor to sort of work all this out up front and then use it over and over again, a repeatable solution. And that doesn't mean that everything has to look and feel the same, because that's kind of the the complaint that we get a lot, I think, with these sorts of buildings, that they all look and feel the same, but I don't think that's necessarily true. We just need to sort of work out up front things like standardized grids, or technically meshes. Now we all work in a 3D environment, standardized interfaces and stuff like that. You know, if we take this classroom, you know, as a Lego brick as an example, the parts on the inside can be configurable to a certain degree. You know, we could swap out this facade panel for a different one, or we could swap out the lighting solution for a different one. But again, just on the proviso that we're following these certain rules and logic, standardized grids, etc. And then, you know, similar to having an embedded level of detail, the same approach applies to the level of information. So again, there's no great mystery about how this is done. It's just we need to know up front what the kit, what's the Lego set, what's the kit of parts, making sure that we have this stored in a centralized way, and most importantly in a structured way. And it's super important, it's critical to the success of this, is that we have structured data, which will then enable all these downstream processes, which, so, you know, PDTs and all that stuff that's going on with CIBSE is super important, but that's not for today's session. So I've got a short video just demonstrating this in a bit more detail. So the video about to watch here highlights this process we're developing, and the digital toolkit that underpins it. So as the title suggests, you'll see in a second, this is for the school's blueprint, but the same concept applies to all sectors, healthcare, residential, etc. So what we're looking at here is this early stage planning, Lego bricks at concept level of detail, how space solutions could be captured in this library for repeat use. You know, again, there's a standardized grid, logically placed, you know, and if we can have different shapes and sizes, but they all have to be, you know, on a standardized grid, bound by certain constraints. Again, we can capture multiple things in here. There could be big clusters, could be the whole art department, or whole sports hall, dining, stacked toilet solutions, even to the point where we're capturing full levels of buildings, or even the whole building itself. You know, here's an off-the-shelf school that you can have that's configurable to a certain level of, to a certain degree, or in different configurations. But like we were saying before, all of this is underpinned really by this standardized platform, and in this case, this is the physical platform, if you will. This is our, what we're calling our S-frame, and it's essentially just a very standardized structural solution with common interfaces on a standardized grid with, you know, very repeatable Lego bricks. And again, if we then drill down into this, all of the design is done up front on the standardized grid. You can see that all of these products are interchangeable, common interface points, and we start peeling back the layers now. You can see how this is made up. There's the S-frame, there's the spaces, here's the facade solution, internal partitioning, modular M&E, and then M&E fit out. And if we zoom in again, you can see here what we're building here is like a configurable menu of products. So as long as, you know, you follow the rules, you could switch this facade panel out for this one or that one. Again, we could switch out the lighting solution, and essentially just, you know, anything could be captured in here. If the client or the designer wants to come up with a new solution, fine, great. But again, we just follow rules and, you know, standardized grid. And just lastly, to touch upon sort of the data point. Obviously, if we know all this stuff up front, this enables some really interesting things to happen. So this is a tool that we've developed. So you can see here that this kit of parts now is known. We know what this is. This is directly from our supply chain. If we know what this is, we know how much it costs. We know how long it takes to manufacture. We know how long it takes to install. So we can get rapid and real-time feedback from the design to say, right, how much is it going to cost? How long is it going to take to manufacture? Again, all of this, as you can see there, that was done quite quickly, but you can see all of this is underpinned here by structured data, GUIDs and stuff like that if you're interested. But again, just kind of touching on that really, that if we do standardize this sort of thing, it enables a lot of clever downstream process. So, video, bear with me. Right. So just on the data side, I think Gonzalo touched upon this earlier, about how, you know, we need the need for standardization, and this is a concept that we put together for a digital platform. And I'll just quickly touch upon the key points, and then I'll hand over to Andy. So there's kind of 4 key areas to it. There's a centralized data environment. So here what we're looking to, this is just basically a big cloud, managed cloud database. And here what we're looking to do is standardize inputs. So that could be your information requirements, asset or employers, design and performance specification, skills and competencies and product data templates or schedules. And again, just making all of this machine readable and accessible to downstream process. One of them being this digital product library. So that's where we're capturing the information, the products, the digitization, making sure that we capture stuff like, design rules, ideals and limits and manufacturing information, pushing those through configuration tools like you've just seen. And again, all of this just ends up in this cloud-based, like you saw that the last bit there, that interrogable, I don't even know if this is a word, a 3D model that's you can interrogate, it's probably a better way of saying it. But again, with supported by this structured data so that we can get time and cost or bill of materials or any other downstream process. Again, it's just all standardized in a structured way. So Andy, I'll hand over to you at this point.
Thank you, Joe. And yeah, good afternoon, everyone. So I don't have any slides. I'm just going to comment really in terms of what Joe's just shown us, and just sort of give you the consultant's view on this. So I mean, if I start with the digital platform, I think there's a lot of synergy in terms of what Laing O'Rourke are looking at in terms of data strategy and what we're looking at as consultants. I guess there's a massive focus in the industry on the data strategy at the moment for a number of reasons. I mean, we have the UK BIM framework and the focus on capturing the client's requirements, the level of information need, and the importance of information management. We have the recommendations coming out of Grenfell, and the need for a golden thread of information. And there's growing interest in sort of digital twin agenda, and including sensors and in capturing in-use data. So we're very much on board with this approach, and I guess in essence what we're looking to do is to have a solution that will go end to end from a data perspective. I mean, for us, I think there's also a recognition that maybe BIM isn't the vessel to host all that information end to end. It's a very important player in this, but we're increasingly looking similarly to kind of move our data maybe away from the likes of Revit. Other tools are available, and Excel, and to move more into sort of cloud-based, web-based solutions, which we think will be the way forward. I guess the key thing for me in the CIBSE environment is it does feel we're at a sort of key juncture with this, and there's an opportunity to be collaborative and all work on solutions together, or we could do learn from the past, or go off and all create our own solutions, which is hopefully not what we're going to do. And the opportunity to collaborate on this and come up with some common standards around the digital platform, that's key. In terms of the kit of parts approach, obviously that's a significant change from a design perspective, and I think the way we're looking at it, if we have modern methods of construction, we're going to have to develop modern methods of design to complement that. So I mean, we still need to work out exactly what that looks like, but for example, to use the car analogy, yes, repeatability, but cars are constantly evolving and improving, and there's still that element of design, and so we can certainly look to bring that to the table. Obviously, there's a lot of interest around climate change and carbon, energy, sustainability. And if we looked at the dashboard, that currently covers cost and time, but we could also bring data into there around carbon and energy and capture that in those dashboards to good effect. We could look at rapid simulation, so the space planning sort of Lego brick approach. Could we take that into our analysis tools and look at form and orientation, that's a possibility. Also, the opportunity to embed design data into those Lego bricks. I think at the moment, conventionally, we as designers, we create a sort of logical design, and that's sliced and diced to create the modules. I think we may reverse that, and it may be we need to stitch that back together with the data that sat behind it to sort of turn it back into a logical system that we can interface with. And I think finally, the opportunity with a sort of factory built solutions to include sensors, and then to capture that in-use data, and then have a complete loop back so that we can use that, capture that data and use it in future designs is all very exciting. So yeah, in conclusion, we're sort of very excited about where this is going and how we might get involved as consultants with this. So that's me. I'll hand back to Neil. Thank you.
Thanks, Andy and Joe. I think there's a lot of really good points that have been made in the previous section. Key one, collaboration. We all need to work through this together if we want to drive change in the industry. And you'll obviously hear about repeatability and standardization. That's a key element to get success in this process. Next slide, Joe. So when we analyse previously completed projects, we are able to surface the opportunities for repeatability and standardisation. The example presented on the screen is an output of a study which Joe's team's completed, which analysed a group of recently completed hospitals to understand where the repeatability lies in the design. So from a space perspective, this study looks at how many spaces are repeated, and of those spaces, how much are the same. So you can see from the right-hand side part of this, we can develop a space kit of parts, if you like, so we can understand where the opportunity lies for standardization and where the opportunity lies for repeatability. So we're using the outputs from this analysis to begin to develop standardized design solutions for each of those areas with a high volume repeatability. So it really gives us a focus to target the areas that will get best bang for buck. And when you actually start looking at data sets, quite often you get given results which don't align with what your previous understandings might be. So it's really interesting working with data, because it does help drive slightly different methodology in terms of where your effort should be placed. So this study really kind of leads us to the position where we can start to build up or create a library of configurable spaces and designs within those configurable spaces, which Joe alluded to during his slides and video. Next slide, please, Joe. We can apply the same principles to the physical M&E design within a given space. So if we go back to common areas, so this particular example is from a school, and it's an M&E design related to a typical classroom. So again, high volume repeatability within the solution. So if we can assess our designs, we can conclude that the opportunity for repeating the key details exists. The design on screen uses pre-selected products from the supply chain, and those pre-selected products have been proved to interface appropriately with each other. So the key point here is that the design solution is already proven to work. It's proven to be assembled appropriately and proven to be tested and operated effectively. So essentially in the design, you're targeting all key parts of the project lifecycle, therefore reducing your level of risk as you deliver the project downstream. So we call this kit of parts. You could effectively think of it as an instruction pamphlet for a piece of IKEA furniture. So the parts are predetermined, they're shown how to come together, and again, that really enables the clarity of design and installation. So what we're looking to do is embedding this product level knowledge into our configurable designs, and that enables us to gain that rapid establishment of a design, and it can enable us to get robust cost, program and sustainability assessments against that, as has been indicated previously. Next slide, please, Joe. So if we take the thought through to its conclusion, the opportunity now presents itself for a radical change in how we procure and deliver materials to site. If we've got a kit of parts, we've got defined products, we can use our distribution and supply chain partners to package a container with all of the parts required for the given space. So the parts will be packaged up in a box and everything will be there for the operatives to go to work within that given space. All of the items of equipment will therefore be delivered in one batch. They'll be ready at the work face to complete the full fit out of the space. So there wouldn't be any waiting around on site for long lead items or sending items back once they're received on site if they're faulty or the wrong item ordered. So we can really get to that position where we can start work once we've got the material, taking the just-in-time delivery methodology from manufacturing onto site. So you can think of the on-site productivity gains that this approach can realise. We can experience a significant removal of time associated with the sourcing of equipment from site storage, for example, or from goods in, or even waiting around for that late delivery, which quite often are quite disruptive to our rate of installation on site. Next slide, please, Joe. So the last example I wanted to share with you is how we can use rule sets to enable a flexible design against project-specific requirements. In effect, having a set of configuration rules, perhaps from a manufacturing perspective, but equally they apply right from the early stages of design. So if we consider a typical LTHW boiler plant skid, how can a product-based methodology drive improvement into the design for this system? On screen, we've got an LTHW boiler plant skid, which we've developed internally. It's based on advanced manufacturing principles, which maximise the benefits of a product-led approach. It uses pre-engineered sub-assemblies, and those sub-assemblies have got defined interfaces, which enable us to get the rapid design configuration against the predetermined manufacturing processes. Next slide, please, Joe. So using the product-based methodology, the skid can be tailored to match the project-specific requirements. We can implement a configurable product by adhering to a defined set of rules, a defined set of constraints, and parameters that will enable the selection and integration of the individual parts, the individual components, and the sub-assemblies which those parts and components comprise, to really bring together the whole to satisfy the project requirements. So using the rule sets, we're able to constrain the design against the functional parameters and the constraints of the individual components. So essentially the design is managed within the capabilities of the performance and also the capabilities of the product. But if we factored in the rule sets for the components and how they can be configured, we can actually begin to swap out each relevant part or sub-assembly to satisfy the bespoke project requirements of the overall product. So if we look at this example, for example, top left, the boiler skid is the boiler elements of the overall. If there's a particular requirement for a boiler manufacturer on a particular project or a particular requirement for a certain heat output from those boilers, we can switch in or out the sub-assembly related to those alternative products. But what will always remain the same is the interface between that component part and the ones adjacent to it. So the key to the success of this, sorry, I get my words mixed up, key to the success is really the pre-engineering of those individual parts and the components and the sub-assemblies to ensure that the interfacing constraints are identified and engineered to resolution. Andy did mention earlier on that this will require a different design process perhaps to accommodate this. You might be on the call thinking that this is going to introduce a lot more design effort, but in reality, there's probably a bit of an uptick in terms of the design effort initially, but once that's gained or once that's completed, then you gain the productivity gains of the repeated use of the pre-designed elements. So furthermore, if we actually codified the constraints and the rule sets, we're able to extend the design productivity further using automated digital tools and parametric or generative design techniques, linking back to the video Joe presented and some of the thoughts that Andy put forward. So if we're really going to drive a step change in how we go to work in the design phase of a project, we need to document the knowledge that we've all got in our own minds, codify that, and that really helps to drive the productivity gains. So the approach simplifies the design process. It reduces the design time from performance requirements definition to the fabrication level design. Therefore, we can drive design productivity and we can reduce the strain on the design programs. I think if we all come from a design perspective, we're all aware of the compression of design programs. Certainly from a contractor's perspective, we're aware of the compression of construction programs. So I think if we adopt novel and alternative techniques, it will really help us be successful in what we do in our day-to-day. That concludes our presentation for today. So hopefully we've been able to illustrate why there's a need for a change and how moving to a product-based methodology can unlock a step change improvements in design, manufacture and assembly. I probably appreciate we might have skimmed over a lot of concepts and a lot of thoughts, but what we've been trying to do is give a bit of an overview, so at least we can start to have the conversation with everyone in the industry about how we facilitate a change and how we try to drive productivity gains within the sector. I'll now hand back to Gonzalo, who's going to field any questions that we've got from the attendees. Thanks for your time.
Thank you, everybody. So, yeah, one question I think that Julian had just responded. Yeah, this presentation has been recorded and the recording will be shared. So yeah, it will be shared in the CIBSE Southwest channel or in the CIBSE channel. We'll provide more information on that, where to find it after this. We have one question from Martin Hayes. It's for Joe, and I think it was when we were showing the video about the stacking up all the modules in the school. That what level of tolerances are applied during fabrication when considering multiple module elements with respect to loading vertically during site assembly?
So there definitely is, tolerances applied. It's not my area of expertise, to be honest, but I definitely know that there's a lot of tolerance applied certainly to allow for the logistics, moving, lifting, shifting stuff around. I don't know if there's anything you want to add on that one, Neil. You probably know more about that than I do.
Yeah, I guess I think from that perspective, we're not necessarily trying to change what we do. We're just trying to package it up in a different way. So I think the tolerances in terms of how we manufacture modules will probably remain the same. The tolerances of how things come together will probably remain the same. What we're kind of suggesting here is that we understand what those are before we get to the point of having to define it. So if we are developing a design as a combined design team, trying to understand how those tolerances come together, quite often we're doing that as a first look on each and every project. What we're kind of trying to suggest here is that we can build intelligence into the process through embedding the knowledge within the products and the process, which enables us to get a start. It might be that we still have to take the review and the validation on the project basis, but certainly the methodology is about capturing what we know now and what can be standardized and repeated. So there might be elements related to tolerance and the build-up of that and how it impacts things on a system level scale that can be surfaced through the embedded data set, and then we can actually take a moment to validate those and review them rather than sort of going back to first principles and working them up ourselves. So I think it's probably we're at the start of that journey. So I'm sure the concept of what we're trying to achieve will move backwards and forwards in terms of its accuracy, but certainly the intent would be that where we have a need for a design decision, we can use the data embedded within the products and the process to help drive a better outcome. But I think there'll always be need for the validation through subject area experts.
Yeah, I think thanks, Neil. It kind of leads on to, there's a next question from Thomas Flynn, which is about future expansion. I think what you suggested there, Neil, kind of leads on to that one as well. And we're not kind of doing anything different to what we do now. We allow for the same capacity, spare capacity, and all the stuff. Like I say, we're just packaging these things up into chunks, into Lego bricks that can be installed faster, quicker, etc.
That's right. Again, as part of the process, the requirements, project-specific requirements, might demand different future requirements. So it might be that there's a capacity change from a certain percentage to another project to project. It might be there's a spatial requirement for future flexibility or adaptability. So it's really about embedding that requirement in right at the very start, and that requirement becomes a data point which is essentially tracked as we go through the process, so we can make sure that as we design, we're not eroding the future capacity, or we're not eroding the spatial requirements. We maintain the requirement that's been defined at the early stages. Joe mentioned the absolute need for having a robust set of client requirements at the start. There will be a need for industry change to get to that point where we can have a robust set of client requirements, but certainly we look to use those requirements as we go through the process to validate the design solutions that are being surfaced.
Another question for Martin. Do you carry out value engineering exercises when developing consultant client designs? And I think the answer to that is yes, from both of us.
Yeah, I think every one of us is involved in trying to make projects commercially viable. So I think that the short answer is yes. I think probably the long-term view would be that if we had an effective product-based methodology, there wouldn't be a need for VE partway through a design process. We'd be able to understand the cost of a project as the design emerges. So we'd really be able to define during the early stages, REBA 2, where we'd be able to set the skeleton, if you like, for the design, and therefore there wouldn't be a need for VE further down the line. But if we take the analogy back to manufacturing, where they would develop the solution, and then if there's a need for VE, they'd probably take it on a component by component basis. So they'd at a point in time, they'd be able to swap out one solution for another if it drove efficiency through cost or performance. So I think in this space, it's probably similar that we'd look to have a process that would deliver value from the outset, and the methodology will deliver design value through increased productivity, but also increased productivity through manufacture and install. So I think the objective could be that we'd get to a position where we'd have a mature approach with clients and projects where we could define the commercial targets earlier on. The client would have confidence in those early targets because we'd be able to surface that through the data sets, and therefore there wouldn't be a need for the client to chase a value management opportunity. So I think the process might drive an alternative behaviour, or hopefully it will drive an alternative behaviour.
I think on the value engineering, I mean, there are two types there, because one is more when, yes, you are doing the design and there is a cost plan, and suddenly there is a brief, and then you do design and there is a cost plan, and then the design, what basically it goes over what's allowed in the cost plan. And basically with a product-based solution, there will be from the beginning, when you are doing that design, you will be knowing more accurately how much it's going to cost, instead of just doing a lot of design to then get the final cost. I think the value engineering, with product-based solution, the value engineering will be more just, you can use manufacturer A or manufacturer B, which one is the top of the market and the one is middle of the market. That would be the value engineering. But in terms, you won't need to omit one floor of a building because you don't have money for that floor. That's basically because you will have a better idea of the cost from the beginning. Yeah.
Just to build on that, Gonzalo, I think the reason that we face these VE or value management challenges during the design process is that we don't have enough confidence or ability to quantify the cost at an early stage. So obviously our QS colleagues, they will progress the level of detail of their cost or their budgets from a square meter rate down to a sort of per unit rate as the design develops. So I think this approach will enable us to get the design maturity at an early stage, and that design maturity will drive a more robust cost position. So I'm hopeful that this will remove a lot of the typical value management conversations that we might have. And as Gonzalo mentioned, if there is a need for despecification of parts, it's just a switch out of one, switch in another, and through the platform that Joe took us through, you could very quickly get an appreciation for what that cost delta would be.
Next one, how much thought is given to OPEX phase data capture? Do you consider the availability and ease of access to performance data for asset management and smarter FM? And does that influence the MEP specification?
Yeah, great question, Dave. I think we've had conversations about this in the past and how the industry needs to consider the operational part of the projects from the outset. I think we're probably at this point in an industry which largely is based on, certainly from a construction perspective, is largely based on hitting a construction cost target or a capex position, if you like. But I think the feedback loop that we could get through this process will enable us to put data from the in-use case back into the start of the project, and that will help to give us more knowledge and understanding of what the designs and the built asset solutions that we put together, how those perform. So it enables us to drive change in specification. So I think the tide will probably shift from us having a sort of a broken feedback loop, which is probably where we're at the moment, where it will happen on an as and when basis based on the needs of the client. So it gets a position where if we've got a methodology that works from a holistic management of data perspective, we can really push data back into the start. And I guess I've got a personal project around challenging design criteria and using in-use data to help that happen. So I think, Dave, absolutely, the need to feed back in would be valued. I think we're probably struggling a little bit at this point in time in terms of how projects are procured, but I think always we'd want to try and challenge that.
Yeah, that one is quite a difficult one, because in traditionally, I mean, you think of the worst case scenario, the traditional workflow, you will have a client brief, then the consultant will have their interpretation of how the building is going to be managed without knowing. Then we'll create employer requirements. Then the contractor will start building it and just choosing specific products to deliver that. And then when you are nearly at the end of the construction is where the FM team starts getting involved, and maybe all the things that have been discussed before, agreed before, are not really suited to the requirements. I think it's all about having that data or collaborating from the beginning, all the parties collaborating from the beginning, knowing exactly what you're trying to deliver from the beginning, not having those gaps, those massive gaps that we have at the moment between the different parties. It's just linking all that together. And then obviously, if you know what information you want to get out when managing the building, you can incorporate that into the design at the beginning. There is quite a lot of focus nowadays on metering and air quality sensors, and it's just how do you want, obviously, how can you improve the efficiency of a building, but increasing the ventilation rates only when it's required because the air quality is decreasing. That's the kind of thing that is getting there, and it's quite important also for the future and climate change and saving energy as well. So yeah. Any more questions?
Yeah, I mean, just on that last point, I mean, from a digital perspective, I mean, the idea that we could, going back to that sort of value engineering, you could simulate the performance of a product through use, but also longer term, if we're capturing all of that in-use data, how useful that's going to be, and we can compare that with the simulation. But I mean, it's not something we're doing a great deal of at the moment, but it feels like there's an opportunity to do that in the future.
Mm-hmm.
Yeah, I've got one more to add to that. I think Dave's kind of alluded to it already. Just sensible decisions around protocol selection, IT interfacing. And it's just, we just need to collaborate early and just agree, structured data sets, make sure we're using sort of open standards and all the rest of it. So then, us as a contractor, we don't want to just build the thing and disappear. We definitely want to sort of build the thing, make sure it's operational, and then monitor the progress and kind of feed that back into our platform so that it can, we build up this big data set of, the last 5 schools that we've built, how they operate, and then that can then get fed back into the next project that we build to make sure that we're doing things better. We improve performance, not only in terms of our, our production and our manufacturing, but also the performance of the actual building itself. So fully agree.
There are no more questions at the minute. I think there is only one point that I wanted to highlight before finishing is, some people will think that, that maybe a product-based solution is not applicable to any type of buildings or any type of sectors. But the reality is applicable to most sectors. Some like education and healthcare definitely is quite an easy. You can associate it really easily. But even you think, oh, the client wants maximum flexibility, you can still provide flexibility with this. It might be that you have a commercial building or residential building, that there are some specific areas that they need to be more bespoke, but that's only going to be like what, 5% of the building. You can still have product-based solutions for 95% of the rest. It's just focusing on that. You can but easily break up any building and basically find repeatability there, and that will always lead for more efficient cost and efficient installation and construction. So I think that concludes the session. Unless you guys have anything else to say?
No, not for me.
No, just thanks for all the people who attended. It's been a pleasure trying to communicate where we're heading as a business, and I think as an industry, I think we've got a big opportunity ahead of us if we all get ourselves together and capture it.
Yeah. Yes. Before we go, just a reminder that next Thursday the session will be on data engineering innovations in the fabrication installation stages. So Joe is going to give a really good overview of what they are looking at the minute. Okay, good. Yep. So thank you very much, everybody.